Hello guys, I present to you the lectures of Professor Rui Fernandes on the topic Positioning Concepts Using Space Geodesy. The presentation addressed the following issues: what is space geodesy, concepts of positioning from space. Geodesy aims to determine exact positions of points globally, the shape and size of the Earth, and studies terrestrial gravity. Space geodesy is different from conventional surveying, uses space-based reference points, not terrestrial. Here are some examples of things measured with space geodesy techniques. Frequency spread by days in milliseconds for 20 years. Station motion vectors for the year. Concepts of positioning. What is meant by the term position of a point? One needs to define a coordinate system, more about this later, describe how the point relates to the coordinate framework. Coordinate frames. Reference to physical points or lines on Earth. The Earth's center of gravity, geocenter, rotation, axis, and the Greenwich meridian are used. They are coordinate frames on Earth and in space, celestial reference frame. Position in the coordinate frame. The position of a point in the reference frame is described by its position vector. In a Cartesian system, the vector will have components x, y, and z. Alternatively, the geographical coordinates latitude, longitude, and height may be used. There are two main categories of positioning from space, namely stellar positioning using stars and more recently quasar as well, satellite-based positioning, GNSS, DORIS. Stellar positioning, used for navigating the sea for centuries. On January 1, 1998, astronomers changed the FK5 optical frame to the International Celestial Reference Frame (ICRF) using 212 radio-emitting quasars. Quasar, quasi-stellar object that is like a star. Very distant objects outside the Milky Way, first discovered in 1963. These distant galaxies strongly emit radio signals. This slide shows a method of a very long baseline interferometry technique. This slide shows a VLBI instrumentation. This slide shows International VLBI service. Satellite-based positioning is further divided into three main categories: transmitting and receiving optical signals to and from satellites, artificial and natural, SLR, LLR, transmitting radio signals to satellites, DORIS, and receiving radio signals from satellites, GNSS. Satellite and lunar laser location. Ground-based station transmits a short picoseconds laser pulse. The laser pulse is reflected off retroreflector on an artificial satellite or the moon. The round-trip time of flight is precisely measured and corrected for atmospheric delay and relativistic effects. Then the geometric range is calculated. Many corrections to range: earth tide, pole tide, ocean and atmospheric loading, tectonic movements. The slide shows SLR techniques. Mission SLR: geodetic, inert massive spheres, for example LAGEOS. Earth sounding and experimental, equipped with, for example, radar altimeters, gravity probes, and others. Radio navigation, for example GPS. These slides shows SLR instrumentation. International Laser Ranging Service. Lunar laser ranging. The purpose is to perform tests to verify Einstein's theory of general relativity. Requirements is millimeters accuracy range to the moon. DORIS, Doppler orbitography and radio positioning integrated by satellites, a network of ground stations transmitting radio signals to satellites. Satellites have accurate clocks on board, accurately measure Doppler shifts in received signals and transmit observations to master control in France. International DORIS service. Advantages of the mentioned positioning techniques. VLBI, very accurate definition of interstation baselines, rotation rate of Earth, Earth's axis, wobble, only absolute system, etc. SLR, very accurate determination of the vertical component and range to satellites, no ionospheric refraction. DORIS, precise orbits for specific satellites and permanent tracking stations. Disadvantages of the mentioned positioning techniques. Very expensive to set up and maintain. Not suitable for surveying applications. Global Navigation Satellite Systems, GPS, Global Positioning System, USA, GLONASS, Global Orbital Navigation Satellite System, Russian Federation, Galileo, European Commission Proposed Satellite Navigation System, Beidou, Satellite Navigation and Positioning System, People's Republic of China. International GNSS Service. Global Positioning System, GPS. Satellite navigation system, only for military purposes in the United States, but now also for civilian, commercial and scientific users. Used for ground-based and air positioning, navigation and time transmission. GPS principles. Time-stamped signals transmitted from satellites contain satellite positions. Signals received from 4 or more satellites are used to determine the four-dimensional position of the receiver. GPS is used in surveying, navigation, exact agriculture, vacation, intelligent transport, and definition of coordinates. This slide shows portable and accurate receiver. And this is an example of multi-purpose receiver. And in the summary, we would like to say that several networks of space geodesy techniques are used for accurate positioning and other geodetic uses. GNSS receivers are relatively inexpensive and practical instruments for positioning and surveying. Thank you for your attention and interest in this information. We're looking forward to see you on our next course.